Okay, today I'm going to do a walkthrough on a new video generation model called Framepack on Grados interface for the RTX 50 series GPU, be it RTX 5060, 5060 Ti, 5070, 5070 Ti, 5080 or 5090 Blackwell cards with customized installation for Pytorch 2.7 using CUDA 12.8. I won't be explaining too much for what Framepack is, since I assume that those who click this video already know what it is and are having difficulty in installing it due to incompatibility errors. But for the uninitiated, Framepack is a new image to video generation model that has two distinct differences compared to others. First, it is capable of generating videos up to 2 minutes, whereas most models struggle with videos beyond 10 seconds. Second is that it has a low VRAM requirement of only 6GB of VRAM without running out of memory. With the quick introduction out of the way, let's get back to the main video objective, which is to run through how to install it on your 50 series GPU. So, for those who try to download and run the default package through the GitHub package, you are probably going to encounter this error, which is runtime error, CUDA error, no kernel image is available for execution on the device. The reason for this is that the 50 series GPU is only compatible with CUDA 12.8 at this moment, and the default package installs Pytorch version 2.6 for CUDA 12.6, which is incompatible with our 50 series GPU. So, to resolve this issue, you need to reinstall the Pytorch with the right version on your Framepack that is compatible instead, which for this case is the Pytorch 2.7 for CUDA 12.8. I hope this explanation is clear enough on why your GPU does not work with the default Framepack installation package. To get things started, go to Framepack page at the GitHub page. Have a quick read on the details such as the requirements and make sure you have them in your systems. Do a quick check by typing NVIDIA-SMI to see that you are indeed using an RTX 50 series GPU capable of supporting CUDA 12.8. Take note that Pytorch comes with its own internal CUDA build, so it can still use your GPU without the need for you to install a full CUDA toolkit. In summary, is that it's fine for you to use these AI tools without the need to install a full CUDA toolkit as long as you install the right Pytorch version. Once the check is done, scroll down to the installation section and click the link that says click here to download one-click package for CUDA 12.6 plus Pytorch 2.6. Once it's downloaded, put it in a folder of your choice, extract it, and do some tidying so that there are not too many duplicated folders. Next, we can have a look at what's under the hood of Framepack. If we click the run.bat file in the main folder and you are using a 50 series GPU, you will encounter the error that I said earlier, which is runtime error, CUDA error, no kernel image, eventually, after it goes through the normal installation process to download the model and so on. The whole installation process is pretty long, so I suggest we will do the 3-step fix first to run on a 50 series GPU before we go through the full installation process. I hope this is clear enough for all of us to understand why we are doing a 3-step fix process first to install the right dependencies before we actually run the run.bat file. Let's move on to the 3-step fix. To summarize this 3-step fix, this involves the first step, which is installing the right Pytorch version suitable for CUDA 12.8, which is, for this case, Pytorch 2.7. Second step is to install the right NumPy version that works for this configuration. NumPy is a mathematical and scientific computing library for Python programming tasks, just for your info. Third is to install flat buffers. This is a serialization library designed for efficiency in demanding a high-performance task and ensuring that minimal memory usage is being used for such scenarios. You will see later why this step is necessary. I found this fix through a discussion on GitHub page, where I will paste the link of description in my descriptions below for your reference. After which I actually tested out this 3-step process and it actually works which is why I'm doing this video walkthrough so that we can have a better visual understanding of the step-by-step process to get it fixed. And also, this is why I hope that if you find this video helpful to you, please give a like, comment, and subscribe to help push this video to the right community who might find it useful as well. Let's move on to the first step. Navigate to your main folder where you have folders such as System and Web UI and files such as Environment, Run, and Update.bat. Go to Systems, then Python folder, and you will be in the folder where all your steps can be executed. Go to the address bar, type cmd, and verify that you are using Framepack's inbuilt Python for all your executions by typing Python space -- version, and you should see Python version 3.10.6. Next, we will execute step 1, which is to force install Pytorch 2.7 for CUDA 12.8. Paste this command in and let it do its thing. Just for an additional note, I will paste all the commands for step 1, 2, 3 in my descriptions below for your ease of copying, but I urge you to understand the logic behind the action and avoid blindly copy-pasting so you won't end up breaking your system. It's usually not that disastrous and most of the things are fixable, but it's still good to know what you are installing. Exercise some patience, read through Reddit and GitHub most of the time, for at least it works for me, while you play around with these tools, and it should help you in fixing quite a few errors. As you can see, it has now found the existing Pytorch 2.6 and is beginning to remove it. And here we will see the first major error, which is a bunch of red text and crazy dependency issues showing that our NumPy version is incompatible. But as you can also see, Pytorch 2.7 for CUDA 12.8 has been successfully installed, so step 1 is completed. We do not need to worry about the errors as we will be resolving them in step 2. Next, we paste the command to install NumPy and let it do its thing. The installation is pretty fast, and you'll see that the previous error has been replaced by something much shorter, stating that Onyx runtime requires flat buffer, which is not installed. So I guess we know what we need to do next. Lastly is to paste in the command to install flat buffer, and all the errors should disappear like magic. After all 3 steps are executed, we are not done with the installation yet, since we only did the prefix to set up for the 50 series GPU. We have not gone through the full installation process yet. So let's go on with the rest of the installation. We will go back to the main folder and click on update.bat first. Windows will protect your PC, but you can just click on more info and run anyways. Once that is done, click on run.bat and do the same for the Windows protection. Next, we can go make a coffee as it will be a very long installation process. Once that is done, you will see the Gradius interface launch on your default browser, and you are ready to use Framepack on your RTX 50 series GPU. But take note of 3 items in your launcher, which is the Xformer, Flash Attention, and Sage Attention is not installed. I'm not an expert on these 3 technologies, but what I know is that their purpose is to reduce generation time. However, they do alter the final product quality by varying degrees. From what I know, installation of these programs for 40 series is pretty straightforward, but it's a little complicated for the 50 series. I will need some time to study and test this out before I release another video specifically on how to install this on the 50 series GPU. With that, we can go back to the Gradius interface, put on a sample picture, type in a few prompts, and test it out. Now, in terms of using Framepack, I'm still testing things out, so I can't really give detailed explanation of each parameter, but I can give a quick basic briefing. First is Tcache, which is another way to make generation faster. What I heard is enabling Tcache can reduce generation speed by up to 40%. In return, your videos might get blurry hands, so you have to balance when to use it and when not to use it. Next is the video length. You can extend to 2 minutes or 120 seconds in total, but of course the longer it takes, the longer you generate, the longer the generation speed will be. Next is the seed, which works the same as a stable diffusion seed, so I will not be going through any explanation on that. Steps and CFG also works the same way. The more steps you choose, the better quality it will be. The higher the CFG you set, the better the prompt adherence. But here the values are slightly different as compared to stable diffusion, and so far I find that the default works fine for me. GPU inference is meant for cards with low memory. Since I do not have such problems yet, I will usually skip this setting. And lastly is the MP4 compression setting, which determines the video output size and how much is compressed when the video is done generating. This is affected by your processing power, so you can play around with the values to see what is the output best suited for your projects. Once you are done with your prompting, hit the start generate and wait for the results. How Framepack works is that it will generate the end frame of the video first, then predict the frames in between and generate actions to match the final frame. It's kind of like a first frame, last frame concept. With that, the generation speed fluctuates depending on the size of the image that you feed into it. For info, I use a 512 by 768 pixel image and it jumped between 20 seconds to 5 seconds per iteration, ultimately taking about 2.5 minutes to generate the first second of the video. At a setting of 25 steps, it averaged about 6 seconds per step to complete 1 second of the video. Rinse and repeat 5 times and you will get your 5-second footage. Here's a look at my GPU usage during the generation, which you can see that 80% of my GPU is being used, 80% of my VRAM is being used during this generation itself. And around 13 to 15 minutes time, we will generate a 5-second clip using the 512 by 768 pixel image, 25 steps with Tcache on. It's not very fast to be honest, but it is still a good tool to use and to keep in your arsenal for different projects. This sums up the basic walkthrough on the installation of Framepack for the RTX 50 series GPU using Pytorch 2.7 with CUDA 12.8. As mentioned earlier, I will definitely try to explore the installation of Xformers, flash attention, and sage attention for RTX 50 series GPUs. If anyone knows how to do it, please leave a comment below and share. I will try that out and release another video as a walkthrough if it works. Also, I understand that there is a Framepack for Comfy UI as well. For those interested in how to install Comfy UI for the 50 series GPU, I'll leave a link in the descriptions if you are curious. However, for now, I won't be installing Framepack on Comfy UI at this moment, since I'm quite comfortable with using the Gradius interface and I have quite a few bits to explore. So remember to like, comment and subscribe to help push this video to the right community that might find it useful. And until then, I will see you when I see you.